In this video, we're going to talk about collisions. There are three kinds of collisions. There's elastic collisions, inelastic collisions, and then partially elastic collisions. No matter what type of collision we have, the conservation momentum will always apply during a collision. Conservation momentum means that the total momentum of both objects before they collide is going to be exactly equal to the total momentum of both objects after they collide. And this could be represented by this equation, where P stands for collision, and P1 is the first object, P2 is the second object. This little symbol is a prime symbol, and it just means after. So we have the momentum of the first object after plus the momentum of the second object, and it's going to be equal to each other. Now, momentum is equal to mass of an object times its velocity, and so we can expand this equation if we replace each of the p's with this mv. We can represent the conservation momentum with this equation right here. Now, total energy is also conserved in a collision. So that means the total energy of both objects before the collision will be equal to the total energy of both objects after the collision. Now, before objects collide, both of them are going to have kinetic energy, which is the energy of moving things. During a collision, some of the kinetic energy will be transformed into other forms of energy, such as heat or sound. Here's what I mean by that. During a car crash, we're going to see that the cars will actually kind of crumple and bend, like we can see in these two cars here. So before these cars collided, they just had kinetic energy. And as they collided, the metal was bending and we had sound release. We had all these different forms of energy. Now here's our first type of collision. We call it an elastic collision. An elastic collision is where two objects are going to collide, and before they collide, 100% of their energy is kinetic energy. After they collide, 100% of their energy is still kinetic energy. So we don't lose any energy to other forms like sound or bending of the objects or anything like that. So in an elastic collision, we're going to have momentum, total energy, and kinetic energy conserved. This is the only kind of collision that conserves kinetic energy. And these collisions only really occur between atoms and molecules. Although we also use billiard balls to represent elastic collisions. Billiard balls are a good example of an elastic collision because they're very hard objects and they don't deform when they hit together. Although they do release sound, and so some of the kinetic energy is transformed into sound energy. Now we can use the following equations to describe elastic collisions. This equation is conservation momentum. It's just saying that the momentum of both objects before they collide is going to be equal to the momentum of both objects after they collide. Since kinetic energy is also just conserved, we can use another equation. This second equation is representing the kinetic energy of both objects. Kinetic energy is calculated with the equation kinetic energy is equal to 1/2 of the mass of an object times the velocity of the object squared. So we're just taking this and putting it in place for each object. Let's see what this kind of collision looks like. I have two examples. In the first example, I have two blocks that are of equal mass. The blue one is going to be traveling at 2 meters per second, while the red block is stationary. Let's see what happens. When the blue block hits the other block, it's going to transfer all of its momentum and kinetic energy to the red block. Since they have the same mass, they must have the same velocity because the momentums have to be conserved. And so the red block continues on moving after the collision at 2 meters per second. Here's another example. In this example, the red block is twice the mass of the blue block. Again, the blue one is going to be traveling at 2 meters per second. When the blue block hits the red block this time, we can see that the velocity is slower. Since the mass has doubled with the red block, the velocity must be cut in half. This is to conserve momentum. And then also conserve the kinetic energy. Here's the next type of collision. It's called an inelastic collision. And in an inelastic collision, the objects will actually stick together after they collide. Now, in an inelastic collision, only momentum and total energy will be conserved. And kinetic energy is not conserved. We're going to lose some energy, in other words, to things like sound and heat and things like that. Now, a good example of an inelastic collision is in football. When one player tackles and wraps up another player, after they collide, they're going to be essentially one object because their masses will be together. They're moving together, in other words. Here's how we can describe an elastic collision. We can start with conservation of momentum because conservation of momentum is still going to apply because any collision has conservation of momentum. Now, after the collision, we can actually simplify this part of the equation because the masses are going to combine together, so it's almost like there's just one object. And so I can say that this new combined object has the mass of the first one plus the mass of the second one, and since they're stuck together, they're only going to have one velocity. And so this is the equation we can use to describe conservation momentum when it applies to an inelastic collision. Alright, let's look at an example of this. In this situation, I have, again, two blocks of equal mass. The first block will be traveling at 2 meters per second, and the second block is stationary. Let's see what happens when they collide. We have to conserve momentum, so as they collide, their mass is going to double because they have equal mass. And so once they are stuck together, their new velocity is going to be exactly half of what the original velocity was. This is going to conserve momentum. The final type of collision is a combination of both elastic and inelastic. We call it partially elastic or partially inelastic. Just like partially inelastic, only momentum and total energy will be conserved. This is the most common type of collision. It's a collision where objects will hit each other and kind of bounce or deform off of each other. They don't stick together. An example of this would be a car crash. Just like the inelastic collision, we can describe this collision with the conservation momentum equation. Since the objects don't stick together, we don't combine the masses on the right side of the equation. And those are collisions.